So it's a staple of science fiction is that planets around other stars might be made of strange and weird elements like a kryptonite or unobtainium or something like this. So is this at all plausible? Could we find new elements unknown to science around other stars?
Well, Paul, the laws of nuclear physics are pretty well set in stone, and we know that, for example, our sun is made out of these elements all the way up to uranium, effectively, and it is pretty hard to imagine how things are going to be made out of things other than this. There is just the tiniest possibility that there are elements heavier out here, but they would be in minute quantities, and so I think we're stuck with these elements, nothing new.
I'm probably also stuck with these sort of ratios, like lots of hydrogen, not much scandium, and so on. The patterns here are once again set by well understood nuclear physics.
And not only set by well understood nuclear physics, you know, our sun is made up of the same stuff that all the other nearby stars are made out of. So we really are formed from sort of the same gene pool.
So if the stars are going to be pretty similar, we then ask about the planets. Planets are not quite the same as stars. Here's, for example, the crust of the Earth. And what you can see, for example, is hydrogen is no longer the highest. It used to be off the scale, but not much hydrogen get trapped in the Earth. There's still some in the water. It's actually oxygen and silicon that are most common in the crust of the Earth. And indeed, the Earth's crust is made of silicon oxides of various forms, also with bits of aluminium in there as well, and some iron and so on, which are called rocks.
Right.
We also have some elements that have fallen almost to the bottom of these plots. These ones are called Cytorophile. It turns out when the Earth was molten, most of the iron sank to the centre, and it carried a lot of other elements, iron-loving Cytorophile elements, down with it. So we lose some things. But by and large, this is about the same pattern as this, only with some well-understood changes. The volatile, the gases never got trapped, and the Cytorophile stuff got sucked down to the bottom.
So, Paul, we have sort of an interesting issue, actually, when we think about it, because my understanding is the early solar system, the carbon and oxygen were bound together to form carbon monoxide.
Yeah, you look here, carbon and oxygen are very similar. So, for example, carbon is much more common than silicon, whereas carbon's really dropped off here.
That's right. And so that maybe suggests that somehow the carbon monoxide was blown away, didn't form the Earth, and the fact that there was more oxygen than there was carbon meant that we got oxygen on Earth, which I'm rather fond of in the form of the water and the air that I breathe.
Not to mention the rocks we're walking on, which is where most of it is.
That's true, yes.
Yeah, so the idea would be that you had fairly large amounts of carbon and oxygen, but a bit more oxygen than carbon. And so when the solar system was forming, they were bound together to form carbon monoxide, which is a very easy thing to form at fairly high temperatures. Yep. And that would mop up all the carbon and most of the oxygen. Whatever oxygen was left over would then at a lower temperature combine with silicon to form rocks, and everything would form. But there's might be one form of getting really... I want some weird alien planets. I want the alien planets to look quite different. And you see, the elements aren't always quite the same. Here, for example, is the ratio of carbon to oxygen in stars around. This is actually a little controversial. There's some papers saying that these points up here are actually wrong. They just failed to measure the things accurately. But nonetheless, there's a bit of a range here. Likewise in things like magnesium to silicon over there.
So you could imagine that there will be some stars, and presumably they're planets, where you have more carbon than oxygen, and we would get a carbon-dominated planet rather than an oxygen-dominated
So this time as it cooled down, once again you'd form carbon monoxide, but now all the oxygen would be mopped up and there'd be some carbon left over. Now when there was oxygen left over before, you can't just form oxygen planets, it has to combine with something, but carbon actually can form graphite. So what you would get is planets made of graphite, and the rest of the carbon might combine with silicon carbides and things. And so you get a planet that's a mixture of graphite and silicon carbide. Silicon carbides are refractory. It's used to industrial processes because it can tolerate heat very well. Indeed, on planets like this, if you had a lot of graphite, when you go below a few kilometers, that's going to turn to diamond because of the pressure. So you get planets with some sort of mixture of silicon carbide and graphite on the center, but then you dig down a few kilometers, you might get solid sheets of diamond all the way around.
So a diamond in the sky, but no kryptonite.
That seems to be the way it's going to be.